channel. Today we will solve the letter combination of a phone number problem. So first we will understand the problem, then we'll discuss the solution, and then we'll write the code in both C++ and Python. Then we will discuss the time and space complexity of our solution. So let's begin with the problem statement. So what it says is, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Okay, so basically this is the keypad kind of thing which is given, and you will be given digits string. So the first example here is 2 3. So what we need to do is print all the letter combinations that the number could represent. So for 2, what do we have? A, B, and C, and for 3 we have D, and F letters. So what are the possible combinations that we can have? We can have A D, A E, A F, and then B D, B E, B F, then C D, C E, and C F. So this is the output which we have to print, and it can be in any order. It need not be lexicographically sorted. The example 2 is, if digits is empty, we have to return an empty vector or empty list. This is example 3. If a single digit is given, we'll have to just print its letters corresponding to this digit, and that will be our output. Let's see what are the constraints. So constraint is digit length can be between 0 and 4 inclusive, both inclusive. That's fine. So if it here the digits length is 0, and hence we have an empty vector as output, and maximum length can be 4. Fine. And digits I is a digit in the range 2 to 9. So digits I is in the range 2 to 9, right? So it will be always between 2 and 9. We cannot have star, 0, 1, or any other digit there. So so it's I mean, constraints are easy to understand. We can easily make intuition out of it, like how we have to handle the corner cases. One corner case will be like when digits is empty, then the output vector has to be empty. So let's understand the solution for this problem. So suppose this for 2 digit 2, the letters which we have is A B C. For digit 3, letters which we have is D E and F. Okay, so for 2 3, what are the possible combinations which we can get? So first what we will do is we'll iterate through the digits, so, or sorry, the letters for digit 2. So what do we have here? A, B, and C, right? And for each of these letters, we will just append the letters corresponding to digit 3. For example, for A, we can map it with D, E, F. So the corresponding letter combination which we'll get is AD, AE, AF. Similarly for B, it can be concatenated with D and F. So we'll get BD, BE, and BF. Now with C again, we can concatenate DEF. So what we will get? CD, CE, CF, right? Suppose we have one more DEF, G, H, I. Suppose we have one more digit called 4. For 2, 3, 4, what do we need to do? If the given input digit string is 2, 3, 4, then we'll have another digit 4. So how will we get that? So what we can do is we can append the letters or concatenate the letters of 4 with the output of 2 comma 3. So for 2 comma 3, this is the output. So for 2 comma 3 4, what we'll do is we'll just append the letters of 4. So what we'll get? ADG, right? ADG, ADH, ADI, right? Similarly, AEG, AEH, AEI, similarly BDG, BDH, BDI, BEG, BEG we already have, BEH, BEI, CDG, CDH, CDI, CEG, CEH, CEI, similarly CFG, CFG, CFH, CFI. So basically what for getting the output for 234, we have appended the letters of 4 with the output of 2 3. So basically what it means is that we can use recursion for this problem, because from recursion what we will get, we can get the output for a sub problem, right? Or a subset of the digits given in the input string, and to that if we append the forthcoming digits, letters with the letters of the previous set of digits, then we'll get the outputs, correct output for the given digit string. So we can use recursion here. So let's see how will we use recursion. So we have 2 3 4 here, right? So for what are the digits do we have here? A, B, C, D, E, F, and G, H, I. Let's just consider 2 and 3 as of now. We'll not consider 4 for drawing the recursion tree. So for 2 we have A, B, C, and for 3 we have D, E, F. So first we, when we are iterating through the letters of 2, what do we have here? A, B, C. So for A we have option either to include, right, or exclude, right? So if we include A, our string, our set temporary solution string will become what? A. And if we exclude A, then what we'll have? We can go to next letter. So next letter will be what? Next letter will be B here, but our string will be null only. So I will just denote it with a phi. So here our string is answer string has become null, and if we include it, right, then we go to the we go to the letter for the next digit, that is 3. Okay, so for 3 what we have? D, E, F. Option is D, E, F. So suppose here we have the option D, E, F. Suppose D, right? D is here. This is A, this is B. Here also our answer string is 5. Here D is there. So we include, I can either I can include D or exclude D. So if I include, um, this is, so let's draw the recursion tree for this problem. Suppose the input string given is 2 3. So for 2 we have A, B, and C, and for 3 we have D, E, and F, right? So let's see how can we use recursion and backtracking and come up with a solution for this. So first we'll consider the digit 2. For digit 2 we have letters A, B, and C. So A we will push in our answer string. So answer string will become A. Then we will go to the, we'll call the recursive function, helper function, suppose helper function for the next digit, which is 3, right? So, and after that we will pop this A. This is backtracking step, backtrack. So basically this we are having a say string answer, which will have, which will store the string which we have to create with the letters of the digits mapped to the mapped to the we have to create this string answer from the letters which are mapped to these digits, right? So for 2 we have a, we'll push a, and then we'll call the helper function for the next digit, and then after calling this helper function we will pop this. Similarly, then what we'll do, we'll push b, call the helper function for the next digit, and then pop b. Similarly, we'll push c in the string, answer string, call the helper function for the next digit, and pop c. Now what will happen? Now when we call helper function 3, so for 3 what do we have? D, E and F, right? So we can push D, then call helper for next digit, right? Next digit is 0, this is 0th index, this is first index, so basically this is helper 1, because this is the index here which we are calling. So helper 1, and this is the input string, right? Helper 1. So this is the input string 2, 3. 2 is at 0th index, 3 is at first index. So that's why I have called their helper 1. This is the index which we are passing in the helper function. Now we'll call helper 2, right? We'll increment the index and call it, and then we'll pop here D. Similarly, we have option for E also. We can push E, then call helper 2, then again pop E, then push F, call helper 2, and pop F. Now what will happen? Like if we push D to our answer string, the answer string will become what? AD, because A is already pushed. Then we called helper 1, so we went to the digit 3. For digit 3 we have these letters D, E, F. So if we push D, our input string will become, oh, sorry, the answer string will become D, and then we will pop it, right? Then we'll pop it, so answer string will become no, after that we are calling this helper 2. So helper 2 is what? Um, at 2 in the index 2, there is nothing, right? Because the string size itself is input string size itself is 2. So at helper at index 2 there is nothing. So whenever the index exceeds the size of the string, we will basically store the answer string in our output vector. So here we will have another vector string output. Okay, so here we have exceeded the size of the input string, so we will push this answer string in our output vector, right? So this will be our waits condition basically. So what will happen here in our output vector here, we will push to OP, right? Push to OP. So in output vector we will have AD. Okay, then we'll backtrack. We will pop D, right? We'll pop D out of the answer string. Then we'll again backtrack and we will pop A also. So our answer string will become null, right? Then what will happen? We'll go to the next character, next letter of digit 2. We'll push B. Our answer string will become B. Then we'll call helper 1. We'll push E. Our sorry, not will not go there actually. After this, after this will come, will basically do it for all the letters of the digit 3, right? So after popping this out, popping this D out, will come here. So we'll have A in the answer string as of now, and then here we will push E. We'll get AE. We call helper 2, and basically here we will push AE to OP. We'll understand all this when we'll write the code, so don't worry if you're not understanding what is going on here. So what will happen? We will have A also stored in our output vector, right? Then what? We'll backtrack, pop E, then we'll come here. Now we will call, we'll go here. So our sorry, current string will become, answer string will become AF, then we'll call helper 2. So basically we'll here push to OP. So here we'll have AF as the string will be stored in, sorry, pushed back to OP vector. Then we'll come back, we'll pop pop F. So we'll go back here. See, now all the letters of the digit 3 are done with. We are done with all the letters, right? So we'll come back here. We'll pop A. We'll backtrack. We'll pop A. Then we'll go here. Then we'll push B. We'll call helper. Again, it will go through all the letters of digit 3. Similarly, for for this C also, we'll go through, iterate through all the letters of digit 3, and ultimately we'll have what, BD, BE, BF, and CD, CE, CF, all these 9 strings in our output vector. So this is how this will work. So basically, if we draw a recursion tree for it, what will we have? Initially will it will be null, then we have A, B, and C, then we have D, E, F. Here also we'll have 3 options: D, E, F, G, H, I. So this is for, if this is the recursion tree for the input 2, 3. Suppose if we have 2, 3, 4, then again we will have, uh, sorry, this will be D, E, F, D, E, F. Again, if we have suppose 4, then the recursion tree will be G, H, I, G, H, I. For this also G, H, I, and again three children for each of these nodes will be there. So for each node here has three children. So how many nodes we will have in this recursion tree? We'll have 1 plus 3 plus how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we will have 27, right? So it will form a geometric progression: 1 plus 3 plus 3 square plus 3 cube plus 3 raised to 4 and so on, right? Suppose the length of the input string is n, so it will go up to 3 raised to n. So what is the sum of a GP? It is a into r raised to n minus 1 upon r minus 1, right? R minus 1. So what is r? R is the common ratio. So common ratio is 3 here, and a is 1. A is the first element, which is 1. So it will be equal to 1 into 3 raised to n minus 1 divided by 3 minus 1 is basically equal to big O of 3 raised to n. So this is our number of nodes in the recursion tree, and hence it is the time complexity of our solution, 3 raised to n, where n is the number of digits or the length of the input string digit basically. So here n is equal to 3, so the time complexity will be 3 into raised to 3 is equal to 27, right? And what is the height of this recursion tree? It is, suppose if input is 2, 3, then the height will be 1, 2. If input is 2, 3, 4, then the height will be 2, 1, 2, and 3. So basically height of this recursion tree. Height of this recursion tree is equal to order of n, where n is the number of so digits in the input string, or basically the size of the input string. So this is basically our space complexity of the recursive function, which is basically equal to order of n. So now we'll go through the program, both the C++ and Python program. First we'll start with C++. So we are given a function here, vector string letter combination string digits. So this is the input string digits, and we have to return a vector string. So we'll just create the vector string output which we have to return. Okay, so and we'll also get the size of the input string, and we will return OP. So in between we have to basically fill the we have to generate the string with the combination of letters, and basically keep pushing it to the OP vector so that finally we get the answer and we return it. So we'll have a string answer which will basically store the current combination of letters, right? So, and we'll call this helper function. We will pass digits, we'll pass n, which is the size of digits, we'll pass answer, and we'll pass OP. And one thing which we are forgetting here is creating the keypad. So this is the keypad which is given, right? So this mapping of digits to letters, this we have to create. So we can use one or like multiple different kind of data structures for this, for storing this information. I'll go with a vector of vector. So we can have a uh, vector of char uh, keypad. Well, let's name it keypad, and its value we can do is how we can initialize also. So what we'll do is for zeroth index, we'll keep it empty because there is no we do not want to we do not need to deal with 0 and 1, right? Because always the input will be between 2 and 9, both inclusive. So basically we will start with 2 and go up to 9. We'll just do the mapping for these digits. So for 0 and 1, I have just kept it empty as it is. So for 2, what do we have? We have A, B, C, right? And similarly, we have to do for initialize for 3, 4, 5, 6, 7, 8, 9. So for 2, for 3, what do we have? D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and we have one more letter here, S. Then what do we have? T, U, V, and we have Z, Y, X, W, right? And so this is our keypad. We'll pass the keypad also to our helper function. So the helper function which will have void return type because we don't want to return anything. We'll just keep appending our answer to the OP vector. So string digits, int n, string answer, vector string, and OP. So wherever possible, we will try to pass the variables, mostly the string and the vectors by reference, so that we do not keep creating a copy of these parameters in every recursive function call. W- Why? Because it will unnecessarily occupy more space. It will waste a lot of space and increase the space complexity. So that's why I have passed digits, answer, OP, and keypad by reference. We can pass int by value because it doesn't really occupy much space as compared to string and vector. So yeah, so what is our base condition here? If and we'll have yeah, we'll have one more parameter called index. So index is basically the current index of the digit string. So and we'll name it as int index. So what is our base condition is if index becomes equal to n, that is basically that basically means is we have gone through all the digits given in the digits string, and now we just want to uh, add our or append our answer string to the OP vector and then just return. So we'll do OP dot push back answer and we will return. Then what? Now this is the base condition. Now how will we handle the recursion? So first we'll find the current digit which we have to deal with. So I'll define an integer variable called digit, which will basically store the um, in which will basically have the digit at the current index. So I'll just do a -0. So we'll get it in integer form, not as a character. So now this digit has an integer, which is basically the digit at the current index. Now what we'll do for in j equal to 0, j less than keypad digit dot size j plus plus. So here basically what I'm doing is for the current digit, I will go through the corresponding letters in the keypad and push the letters in our answer string, right? And then call the helper function again and then pop the current letter so as to backtrack. So I'll just write the code, then you will understand. So first thing is, yeah, I have to push it to our answer string. So what we are gonna do, we'll push keypad digit and then J, then call helper with digits N, answer, OP, keypad, index plus 1, and then pop it back, right? So here we are pushing the current character, right? We're iterating through the characters for the current digit, and one by one we are pushing it to our answer string and calling the helper function for the next digit, and then we are popping the current character, whatever we had inserted, we are popping it back. So this is the backtracking step. So let's run it and see whether we are getting the correct answer or not, whether our answer is getting accepted or not. So no, there is compiler error, so it should be answer dot pop back. Let's run it again. It's a wrong answer for case 2. Okay, so we have not handled. Okay, so when the digits is empty, then it has to be an empty vector, and what I am returning is a vector with an empty string. So basically what we need to do here is if n is equal to 0, then return OP. Now let's run it. So this is a corner case which we should handle. So now I'm submitting this. Let's see whether it is getting accepted or not. Yeah, so it's accepted. Now we'll write the Python code for this problem. So we have letter combinations. Our OP list is empty and is the length of given string. Then what else do we need? Yeah, we'll need answer string, an empty answer string. Then we need int index maybe. No, that we can pass that directly. And we have to check the write the code for the handling the corner case. If n equal to 0, return OP. Otherwise, call the helper function. Will pass digits. Will pass here OP. Will pass n. Will pass answer. And the current index, which is 0, and we need to pass the keypad also, which we need to create first. So, and then finally return OP, right? So, yeah, now I need to create the keypad. So I'll create it here. So it will be basically a list of list. Wait, yeah, here we will have A, B, and C. Similarly, we will create the list for or the sub list for 2, 3, 4, 5, 6, 7, 9. It will be what? D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and one more S, T, U, V, W, X, Y, Z, right? And we'll just remove this comma, extra comma. I think I'm doing something wrong here. Let's see if I'm getting any syntax error. I sometimes get confused. Yeah, I think just one is needed, just one slash. Okay, now this is fine. It is getting confused here. So we'll create the helper function quickly. Def helper, and what do we need to pass? Self, then digits. What is OP vector? N, answer, index, and keypad. Right? If we'll just write the base condition, if index becomes equal to n, then op dot append answer, then return, otherwise digit is equal to int um, digits index, and then run a for loop for change range 0 comma keypad digit length. I think, yeah, it's fine. For change range 0, comma length of keypad digit, will answer, will add the character basically. Answer is equal to answer plus keypad digit J, and then we will call helper function, increment the index so that we go to the next character, next digit, and then we will, what we will do, we will just remove the last character which we have just appended. So I think it should give us the correct answer. Let's see what are we getting here. So I need to add self dot. That's a wrong answer. Amazing. So what is the output we are getting? ADAEAF BDBE ADAEAF BD. Okay, A is basically not getting removed here. So AEF BD ABD AEAF ACD AEF. So looks like we are messing up somewhere while it doesn't have a copy. Okay, it's a string. So I think we are messing up somewhere here. Let me just quickly Google append char to list in Python. Okay, we have an option here, char to string. I'm just checking the syntax because sometimes I do not use Python so frequently, so I'm just checking the syntax how to add a character to a string. Yeah, so this is fine, right? What I'm using is correct. And now I have to check how to remove the last characters from a string. Let's see. Yeah, this is what I did, right? Acha, okay, okay, I got it. It should not be n. Hmm, n is not what I want here. It should be length answer minus one. Yeah. Now this is accepted. Yeah. So solution is accepted. Thank you so much for your time. Please let me know in comment section if you have not understood any concept. Please like the video and subscribe to my channel. Thank you so much.